In this video, we'll explore how to build rich search experiences using BuildShip and its integration with MongoDB. MongoDB is a popular open source NoSQL database known for its flexibility and scalability. Beyond that, it offers powerful full-text search, vector search, and hybrid search capabilities, allowing you to create highly relevant and advanced search functionalities. When paired with BuildShip, we'll uncover a streamlined approach to enhancing search for your websites and apps through an intuitive low-code interface. But enough talking, let's jump into a demo of one of the search functionalities we'll be building in this video, full-text search. Here we have a BuildShip workflow that's using the MongoDB full-text search node. This node will perform full-text search on the specified MongoDB collection we enter. For the purposes of this demo, let's say that we want to perform full-text search on a movies collection. Let's put our MongoDB-powered full-text search workflow to the test. Here we can enter a partial text of a particular movie we're looking for, and then we can test this workflow. After a few seconds, we get back our full-text search response. The response contains all the matching documents for the search query we entered. In this case, we're only getting back one document, where the movie title is set to The Lord of the Rings, The Return of the King. Perfect. For the rest of this video, we'll build two types of search experiences using BuildShip and MongoDB. We'll cover setting up a MongoDB Atlas project, where we'll create a MongoDB cluster, initialize our database, and set up our movies collection. Building full-text search using the MongoDB full-text search template. Finally, building semantic search using the MongoDB create embeddings and semantic search templates. Let's begin with full-text search. Before we start working with our full-text search workflow in BuildShip, let's create our MongoDB Atlas project. MongoDB Atlas is a cloud service for hosting your MongoDB clusters. If you already have a MongoDB Atlas account, then you can just sign in. Otherwise, you can create a new account. I'm already signed in into my MongoDB Atlas account. From here, what I'll do is create a brand new project. The first thing I'll need to do here is give my project a name, so I'll call this BuildShip Demo. Then we can proceed. Here we can add members to our project. By default, it will select my current logged in user session, so that's okay. After that, we can just create the project. Once our project is created, the next thing we'll want to do is create our first cluster. Let's click Create to begin. Here we can select the specification tier we would like to use for our cluster. For the purposes of this demo, we'll just go with the free tier. Next, let's give our cluster a name. We'll change this to Demo. Then we can leave the other options set to their defaults. From here, we can click Create Deployment. Here we're given our login credentials that we'll need later to connect to our MongoDB cluster. For now, we just need to keep note of our username and password. So I'll just copy this to my clipboard for now. Then for the time being, I'll just paste the database user password in my notes. Of course, you never want to expose your database credentials to anyone. For the purposes of this demo, this isn't a big deal because at the end of this video, I'll be deleting this MongoDB project. We can close out of this modal. And next, we need to update our cluster's network access to give BuildShip permission to connect with our MongoDB database. Let's navigate to the network access page. Under our IP access list, we have a default IP address that was added here as part of the automatic setup process. We can delete this. And then we'll want to add our own IP address. And for the access list entry input, you'll want to paste this value. This will give our MongoDB nodes the ability to connect to our MongoDB database. We can just confirm. And that's all the network access configuration we need to do. Next, we'll want to create our first database inside of our cluster, and then initialize our movies collection with some sample data. To begin, we'll navigate to Database. And then here we'll click Browse Collections, and then we'll want to add our own data. Then we need to enter our database name. We'll enter BuildShip. Our collection name, we'll call it Movies. And then we can just click create. Now we can start seeding our movies collection with some sample data, which we'll use to test full text search and eventually semantic search in BuildShip. We'll pause the video here and resume after we've added some movies to our collection. I've now imported some movies into our collection, with each one having a title and a short description. There's one more step that we need to fulfill in our MongoDB database before we can switch over to BuildShip and start working on our full text search workflow. What we need to do is create an Atlas search index. Creating a search index for our collection will enable for faster retrieval of documents. To begin, let's switch over to the Atlas search tab. And from here, we'll create a search index. We'll select Visual Editor and click Next. Next, we need to give our index a name. We'll enter FTS, that is an abbreviation for full text search. Next, we need to select the database and collection we want to create this index on. Under our BuildShip database, we'll select the movies collection, and then we can click Next. If we scroll down to the bottom, we can now create our search index. This will take a few moments to create. Our index has been created and is now active. If you're thinking to yourself that was quite a lot of setup to do before you can even get started working on search for your apps, then don't worry, because it will all be smooth sailing from here on thanks to BuildShip. And speaking of BuildShip, let's start working on our full text search workflow. Let's switch over to BuildShip, and we're currently on the templates library page. From here, we'll search for MongoDB, and then we'll select the MongoDB full text search template. And as you can see, this is a pretty straightforward workflow. At the top, we have a REST API call trigger with the API endpoint path set to full text search and the HTTP method set to post. The crucial part here is the MongoDB full text search node. And this node is all we need to be able to perform full text search on our MongoDB database. There's some configurations that we need to do before we can start putting this workflow to the test. The first thing we'll need to do is enter our database connection string. We can get this connection string from our MongoDB database. We just go back to database, click connect, select drivers, select Node.js. If we scroll down, we'll see the connection string here, and we can copy this. Now we'll need to substitute our password here. So I'll just bring up my notes, and I'll paste our connection string here. And then I'll copy the password I previously pasted here. And then I'll just replace password with the actual password. And that's our database connection string. So we'll copy this. We'll go back to our workflow and we'll paste this as our database connection string to use. Next, we need to specify the name of our database. Since we called it BuildShip, we don't need to change this here. And then we need to specify the name of the collection inside of that database that we want to perform full text search on. So we'll change this from documents to movies. The query input is where we pass the search term that will be used to perform the full text search. We'll be passing this value as part of the request body. And then lastly, we need to specify our index name. And since we called it FTS, we don't need to change it here. And the final node in this workflow will just be to return the result from our full text search node. And we're now ready to put our full text search workflow to the test. Let's go to test. And I will switch to the body tab. And then here we'll need to add our search term. This will be in the form of a JSON object with a data field. And the value of that data field is the search term or partial search term that we want to use to perform full text search on our movies collection. So here I'm just entering night. Now let's test the workflow. And after a few seconds, we do get back a result from our full text search. And we can see that the movie that is returning is The Dark Knight. We can further verify this by switching back to our MongoDB database. And then here you can see that we have The Dark Knight movie. Let's test our workflow again. And this time we'll enter a different search query. Let's say that we want to search for mafia-related movies. So we'll just enter the keyword mafia here and test the workflow. And this time we're getting back two results. The first one being the movie Goodfellas, and the second one being the movie The Godfather. And we have mentions of the mafia keyword in both of these documents. Perfect. So it's safe to say that our full text search workflow is working And our MongoDB full-text search node is providing a flexible and powerful full-text search experience with minimal setup or configuration required. And in fact, usually to get something like this working, you'd have to write a good amount of code. But with BuildShip, you don't have to worry about that. Do keep in mind that the underlying code for this full-text search node is available. We can actually preview this. And now that we've covered full-text search, let's now look at how we can implement semantic search with BuildShip and MongoDB. Semantic search is extremely powerful in that it allows you to find records that match the meaning of a search query. This means that by using semantic search, you'll be providing your users a way to search for information that understands the meaning behind the words or search query they enter, rather than just looking up exact matches of the words themselves, as in the case of full-text search. To get started with semantic search, we must first create embeddings for each of the documents inside of our movies collection. Embeddings are just a way of capturing meaningful relationships of the documents inside of our collection so that we can perform tasks such as semantic search and retrieval. Let's begin. First, we'll use a BuildShip template for generating embeddings for each of the documents inside of our movies collection. And then after that, we'll need to create an Atlas vector search index. Let's go to the templates library. And then we'll search for MongoDB. And then we'll select the MongoDB Create Embeddings template. We'll use this workflow to create embeddings for each of the documents in the specified collection. First, we need to configure the query collection node. We use this node to retrieve a set of documents from a particular collection. The first thing we'll need to enter here is the connection string. Let's just switch back to that previous template. And then we'll copy the connection string from here, and we'll paste it here. Our database name is already correctly set to BuildShip, but we need to change our collection name to movies. We can ignore the query sort fields, and the projection input is where we define the set of fields we want to return from our collection. Let's open this up. And currently, it's returning a field called content, as well as the document ID. If we go back to our database, we can see that we have no content field, but instead we have a description field. So this is the field we'll want to return. We can actually test if this node is configured properly and is working. Just click the play icon, and then we can run the node. Nice. We can see that we're getting back all the documents from our movies collection. After we retrieve these documents, what we want to do is iterate through each of them and generate an embedding for each one. In particular, we're going to be generating an embedding for the description field, and then we're going to store the embedding as a new field on the movies document. We'll be generating the embeddings using OpenAI. We have a generate embeddings node that we'll use, and we'll need to select our OpenAI API key here, and we'll just grab that from our secrets. The next field, content, is where we specify the data we want to generate the embeddings of. Let's bring this up. And we'll need to change this. Instead of content, we'll use the description field from our movie document. And next, we're using a MongoDB update document node to store that embedding on the movies document. So we'll need to enter our database connection string again. So we'll just copy this and paste it here. Our database name is already set correctly. We just need to change the collection name to movies. And then let's verify document ID. This is correct. And then let's look at the data that we're updating. So we're updating an embeddings field on our movie document, and we're setting it to the output of our generate embeddings node. And then we just return the results from our update document node. Now let's have our workflow do the heavy lifting of generating the embeddings for each of the movie documents we have stored in our collection. To get started, we'll just go to test, and we can just test the workflow. Perfect. Our workflow has finished generating the embeddings for each of the movies document in our collection. And we can further verify this by going to our database and clicking refresh. And then now each movie document has a new embeddings field. Beautiful. Our next step is to create a vector search index. Let's navigate to the Atlas Search tab. And then from here, we'll click Create Search Index. Then we'll want to select JSON Editor under the Atlas Vector Search section. And then click Next. First, we need to select the database and collection we want to create this index on. So under BuildShip, we'll select Movies, and then we can leave the index name set to Vector Index. And then we'll need to update this JSON with a different configuration. To get that, we'll go to the BuildShip documentation for semantic search. And then we'll copy this JSON configuration, go back to Atlas, and paste it here. The type field here indicates the field type, which is currently set to vector embeddings. Path is the field name where we have stored our embeddings. If you recalled, on each of our movie documents, we have a new embedding field. Num dimensions is the number of dimensions in the vectors. Because we're using OpenAI, we're setting this to 1536. And lastly, we just specify the function we want to use for comparing the vectors. Now we can scroll to the bottom and click Next. And from here, we can just click Create Search Index to start creating our vector search index. We just have to wait a few moments for this to create and become active. And our vector search index is now active. That means that we're now ready to start working on our semantic search workflow in BuildShip. Back in BuildShip, we'll go to the templates library. We'll search for MongoDB, and this time we'll select the MongoDB semantic search template. And just like with the Fulltext search workflow, this is using the REST API call trigger with the endpoint path set to semantic search and the HTTP method set to post. But the main part of this workflow is the MongoDB semantic search node. Let's start configuring this node. And the first value we'll need to enter here is our database connection string. We'll just go back to one of our previous workflows and copy the connection string here and then paste it. Our database name is already correctly set to BuildShip. And since we're using embeddings from OpenAI, we need to enter our OpenAI API key again. So we'll just grab this from our secrets. We can leave the default embeddings model. And then our collection name is movies. For our new search query, let's say that we're looking for a movie that is set in the medieval ages. Our index name is already correctly set to vector index. We can leave the default candidates to consider set to 150, and we can leave the number of documents to return set to 10. That's all the setup we need to do for our semantic search node. And then the last node in this workflow is to just return the results from our semantic search node. Let's put our workflow to the test. Great, we're getting back the results of our semantic search. And the first movie we get back here is The Lord of the Rings. And if you've ever watched any of the Lord of the Rings movies, then you know that they are indeed set in the medieval ages. And notice in the description of the movie that there's no mention of medieval whatsoever. And this is where the power of semantic search comes into play, where we can match documents based on the meaning of the words we enter or search for, rather than just looking for exact search terms themselves. Now that we've reached the end of this video, you've seen for yourself that pairing BuildShip with MongoDB will enable you to build a powerful and modern search experience for your websites and apps. What's even better is to be able to do all of this in a streamlined and low-code manner by using BuildShip. There's no need for writing any code here. Simply plug in the type of MongoDB search node you want to use in your workflow, ship instantly, and start integrating into your apps so that your users can effortlessly and quickly find the exact information they're looking for. And remember, if you found any of the steps confusing in this video, then you can always refer to the BuildShip documentation on MongoDB search integration for step-by-step instructions on how to get full-text search, semantic search working. There's even one more type of search that you can take advantage of. That is hybrid search, which is a combination of the best of full-text search and semantic search. but we'll leave this up to you for further exploration. You'll be able to find the documentation link below this video. Lastly, if you found this video interesting, then don't forget to subscribe to our channel if you haven't done so already. And while you're still here, we'd love to hear your feedback or any ideas you may have for what you'd like to see us build next. That's all we have for this video, and until the next one, happy build shipping!